You see somebody solve a Rubik's Cube, then you might think that they're either a genius or that they cheated in some way. And if you do not think that they cheated in some way, then you might think that they are a math nerd of some sort, like this person. But then there's a question. Could you solve a Rubik's Cube using actual math? Now, obviously, us cubers do not use actual math like algebra and calculus to solve a Rubik's Cube. What if you actually could? In this question, I'm going to be explaining all of that. So stay tuned and enjoy the video. Also, make sure you like and subscribe. I put a lot of time and effort into these videos, and I hate to see it just go to waste. Okay, now let's begin. Group theory is a form of math that can resemble the situation of the Rubik's Cube. For example, we have something like permutation groups, which is a set of elements, which is face rotations, that rearrange the 54 visible facelets, which is 9 on each side and 9 on each side of the 6 sides. Now, if you don't know what a facelet is something like one of these things, where there's 9 on each side, and there are 6 sides, of course. And the cube has about 43 quintillion possible positions, which if you've never heard of before, you might think I'm actually joking, and that this number is absolutely insane, and there will be no way to get this. But with the corners being in exactly 8 different positions it can be in, and the edges being in 12 different positions it can be in, and the fact that the corner can be twisted into 3 different positions, and the edge can be flipped in 2 different positions, multiply all of those numbers and we get 43 quintillion. If you want me to actually do the math, then maybe I'll come up with a video of that. Now, to actually solve the cube, you have to use stuff like commutators and conjunctions. Now, I'm going to simply explain these two. Now, a commutator is something like x, y, x, negative 1, y, negative 1. Which, if you don't know, let's say that x is a simple algorithm like r, u, r prime. Okay, and then y is another algorithm that's something like r prime, d prime, r. Now, if we follow this pattern, then that is called a commutator. Now, let's do that. Now, first we do x, which is r, u, r prime. Then we do y, which is r prime, d prime, r. And then now we do x negative 1, which is r, u prime, r prime. And then y negative 1, which is r prime, d, r. Now this is a commutator, and it doesn't necessarily look like a commutator if you know 3-blind, but this is actually a commutator. Yeah, you probably won't necessarily use it because it doesn't really do anything important that you would need for solving. Now, if we simply just undo all of this, then it goes back to the solve state, which is kind of useful. Now, there are also conjunctions, which is x, y, x negative 1. Now, if you know already the commutators, which I just showed, then you would know that if we do x, which is r, u, r prime, and we do y, r prime, d prime, r, and we do x negative 1, r, u prime, r, then that would be a little set, which is a conjunction. So this would be a conjunction, which again, doesn't really do anything necessary for solving the cube. Now, this thing, you can actually do the exact same thing and it will go back to its solve state. Now, if you don't know what I mean by that, let's follow this again. Now, we do x, then y, and then x negative 1. And we're back at the solve state. Now, in conclusion, math can be used to solve a Rubik's Cube, just not the way you think. Now, group theory isn't actually a way you can solve Rubik's Cube. It's a way to sort of stimulate the Rubik's Cube possibilities and what the Rubik's Cube actually is when compared to using math functions and stuff like that. Now, to actually solve the cube, you can use commutators and conjunctions, which I just explained. Now, using commutators and conjunctions, you can create your own method to solve the Rubik's Cube. It just would take a while and you would need to improvise your method a lot. Now, you might know commutators and if you do 3-bond, like I said, because in 3-bond, you will do commutators, something like this. If you do advanced 3-bond, then you will probably do something like that. Or in FMC, which is Phoebe's Smooth Challenge, you might do commutators, stuff like that. But beside the point, math can be used to solve a Rubik's Cube. It will just take a while, it will be very hard, and you can't use actual math methods like algebra or calculus and stuff like that. Now, anyways, I do not have much other stuff to add. All I have to say is that math can be used to solve Rubik's Cube, which is exactly why you clicked on this page, to realize if Rubik's Cube can be used, if math can be used to solve a Rubik's Cube. Anyways, I'll see you guys next time. If you enjoy some of these videos like this, then make sure you leave a like and subscribe. I put a lot of effort into these videos, and I hate to see it go to waste, which I said at the beginning, but I'll state it again. Anyways, I'll see you guys next time. See ya.